A retailer had been selling 1,200 tablet computers a week at $350 each. The marketing department estimates that an additional 80 tablets will sell each week for every $10 that the price is lowered. A. Find the demand function. B. What should the price be set in order to maximize the revenue? C. If the cost is C of x equal 35,000 plus 120x, what price should it choose in order to maximize the profit? First, we find the demand function. We assume that the demand function is a linear function. It is the price function in terms of x. At the moment, 1,200 tablets are sold at the price of $350 each. If x is 1,200, p is 350. If we lower the price by 10, 340 each, then we would increase the number of units by 80, 1280. Assuming that this is the linear function, to find the slope, we take the change in y, which is 340 minus 350 over the change in x, 1280 minus 1200, which is negative 10 over 80, or negative 1 over 8 as it should be. If x increases by 80, then y decreases by 10. If the price decreases by 10, then the number of quantities sold increases by 80. And that is what the slope is telling us. Simplifying this is negative 1 over 8. We now find the y-intercept, but the equation p of x is mx plus b, where we found m to be negative 1 over 8. We now need to find b. To find b, we simply plugged in any of the points to find b. If we plugged in 1,200, we have negative 1 over 8 times 1,200 plus b, and this needs to give us 350 for y, where y is the price per unit. Negative 1 over 8 times 1,200 is negative 150. Negative 150 plus b equals 350, so b equals 500. The demand equation is therefore p of x equals 500 minus 1 over 8x. What should the price be set in order to maximize the revenue? The revenue is the price times the quantity. The quantity in this case is the number of units sold, and the price is the equation for the demand, which is 500 minus 1 over 8x times x. This is 500x minus 1 over 8x squared, and this is the revenue equation. In order to maximize the revenue, we would need to find the derivative, which is 500 minus 1 over 8 times 2x, or 500 minus 1 over 4x. We set it equal to 0, and we have 1 over 4x equals 500, so x equals 500 times 4, which is 2,000 or 2,000. But this is not the price. We're looking for the price, and we have the quantity. The price in terms of x is p of 2,000 equals 500 minus 1 over 8 times 2,000. This is 500 minus 1 over 8 times 2,000 is 250. 500 minus 250 is 250. So this should be the price if we want to maximize the revenue. Next, to maximize the profit is the revenue minus the cost. We have the revenue equation, and we are given the cost. the profits P of x is the revenue minus the cost, where the revenue is 500x minus 1 over 8x squared, and the cost function is given. It is 35,000 plus 120x. Simplifying this, we have 500x minus 120x minus 1 over 8x squared minus 35,000. 500x minus 120x is 380x minus 1 over 8x squared minus 35,000. We then take the derivative of the profits function to get 380 minus 1 over 8 times 2x minus 0, which is 380 minus 1 over 4x, and we set this equal to 0. We have 1 over 4x equals 380, so x equals 380 times 4, which is 1520. But again, this is not the price. We're looking for the price. The price function P of x, so P of 1520 equals 500 minus 1 over 8 times x. X is 1520. We have 500 minus 1 over 8 times 1520, which is 310. This is the price to set if we want to maximize the profit given the cost function.